All right, you guys. So this is the last part review for tomorrow's. No, you guys are Thursday, right?
Yeah.
Thursday's test. We did the other part. If you were online, again, there's no calculator. To the page of notes, but no headphones. Okay. If you're online, no headphones. Okay. Never know if somebody's letting you know somebody's answers, so no headphones at all.
Oh.
Okay. All right. So this should be quick, not too long. At least just half the period. We'll go over a few of these. Rolle's theorem. Okay, you will have that. We'll refresh your memory with this right here. Okay. So when you're showing Rolle's theorem, the other class up for Mr. Master's class, they got to reinforce this right here because in their quiz, some didn't show it. So to be fair, let me make sure we reinforce it. Okay, and this is where I'm showing it to them. We want to show that f is continuous on this closed interval a and b. All of that is just through inspection. Okay. The other one is it differentiable on this open interval a and b. Okay, and we'll talk about how we can show that. So these are the other things, especially this one. This is what I'm really looking for to justify Rolle's theorems. Yeah, it's a little bit of a pain, but it's just a process. In order to go through it, we have to complete these steps. Okay, we need to show that f of a is equal to f of b. Now, if we look at this graph right here, this happens to be continuous right here, but it is not differentiable at this point right here. I forgot what we did actually have one equation like that, I think. I just can't remember where it was. Okay. No, it's not an asymptote. It's just not differentiable at that point because we took the derivative, and we'll talk about we took the derivative and found that it is it equaled it was yeah, well, the denominator. I can't even think of the word. What is it when a function has 0 underneath it? Undefined. Okay. All right, let's look at this right here. And we'll look at the next one. So we're going to use Rolle's theorem. I will put this on the quiz right here. So you want to follow these steps. One, is it continuous? Okay. And all you got to do right here for one, is it continuous? Anything stopping it? Anything going to show undefined? No. So yes, so it is continuous. I don't need you to put, okay. 2, is it differentiable? So here's what we'll do. I mean, you can tell by looking at it, it is. But just take the derivative of it. 4x cubed minus 4x. Because we are going to need this 4x. Okay. Now that it's our derivative, it means, we could take a derivative of this function, but looking at this derivative, is there anywhere where it would show that it is undefined? No. So this means that it is differentiable everywhere. Okay. One thing we're doing is we're focusing on an interval. So let's say you had something just hypothetically look like this. And then, it had a hole out there somewhere. This is just all hypothetically. And it was -2 to 2. Okay. Is this function in general, is it continuous? No. But on this interval, is it continuous? Yeah. Yes. So that's why it's important with this interval we're talking about. All right, the next step you got to show, step 3, f of a is equal to f of b. Okay, so this is our A, that's our B. So f of -2 is equal to -2 to the fourth minus 2, -2 to the fourth. This is what? 16. 8. Oh, it's supposed to be, sorry.
It's 2
Squared.
times 2.
Okay, so it's 8, positive 8, which equals 8. Okay. And then f of 2, 2 to the fourth minus 2 squared, 16 minus 8 equals 8. Okay, so that part checks out. I do want to see that work on there. So the last thing we need to show that there is some c of this derivative that equals 0. Okay. So from here, we already got our f prime. Okay, so we'll go f prime of c is equal to 4c cubed minus 4c, set that equal to 0. Okay, we got 4c in common. 4c, c squared minus 1 equals 0. 4c equals 0. C equals plus or minus 1, so c equals 0. Okay. And what were these c's again now that we've done the summary of a sketch curve and all that? What were those c's again? What do those represent?
Critical point.
Critical points. Okay. All right, let's just look at this one right here. 1. Is this continuous on this interval, -2 to 2?
No.
No. Where is it not continuous at?
0.
0. So we cannot go on any further. If it said 1 to 2, then yeah, we can go on further. Okay, any questions on those? All right. Okay, mean value theorem. Okay, so a lot of times we're trying to find that C where we could have this, again, I will post it on there so that you can see the steps on there. What is the difference between mean value theorem and Rolle's theorem? What don't we have to do? Yeah, we don't have to do we have to do derivative, but what, FA and B, but you can do it and show it like this. I prefer to just find a C doing that. Okay? So let me get this.
Wait, Mr. Dioso,
Yes.
Ryan told me to tell you to answer Max on there.
Answer Max. Oh. Let me see the participants thing. It should be all enabled. There we go. Are you guys all in now? I don't know what's going on with my sound. You guys all in? Can you hear me? All right.
We can hear you, but
Okay.
I don't think. Can you hear us?
Yeah, I can hear you.
Okay.
Something's wrong with sound. All right, so Max, Colin, we just went over the first part of Rolle's theorem. Okay. And now we're going to do the mean value theorem. This will be on your exam. Okay. And so, well, it's already there. Let me kind of get rid of this. Okay. So here, mean value theorem, we're trying to find all the C's that satisfy the conclusion of the mean value theorem. So, looking at this, 1, this is continuous on this interval. Okay. 2, let's take this derivative of this, 3x squared. This is technically, let's write it like this. 3x squared minus 2x minus 2. Okay.
Mr. Diaz, how do you know it's continuous?
Well, on here, is there any point, even within this interval, where it would be undefined?
No. Okay.
Okay. All right, so here on our second derivative, okay, is there any point where we plug it in and it is undefined on there? So yes, this is differentiable at all points. I'm just going to put diff. We're going to end up using it again later.
So wait, that's because there's no,
Yeah, there's no x on the bottom. Okay. Especially within that interval. All right, we don't have to do our f of a or f of b, but to show it, but we still have to because of this right here. So let's do our f of a. Again, this is a little bit of just a pain. Make sure we're doing it in the original function. Okay. That is -1 cubed minus 1 squared minus 2 minus 1, which equals, thank you. Okay. Which equals, what is that? -1 minus 1 plus 2, which equals 0. Okay. F of b equals f of 1, which is 1 cubed minus 1 squared minus 2, and that is -2. Okay. So f of b minus f of a equals b minus a. So f of b, -2 minus 0. B minus a.
Can you scroll down?
Oh. B minus a. That is, was it 1 or 1? Yeah. Which is -2 over 2, which is -1. Okay, is it done? What do we still have to find? C. Okay, we're using that f of c is equal to f of b minus f of a, b minus a. So our f of c is up here. Okay, we're just going to plug c's where all those x's are at. So we have 3c squared minus 2c minus 2 equals negative 1. Okay, oops, low. We'll set that equal to 0. 3c squared minus 2c minus 1 equals 0. And we'll 3c, c, 1 here, negative, positive. Okay. So our c is equal to, let's just write it out, 3c plus 1 equals 0, 3c equals negative 1, c equals negative 1/3. The other one is c minus 1 equals 0, c equals 1. Okay. Are both of those in the interval? Yes. Okay, so you have those two on there, and I'll give you this theorem right here. Make sure we follow it. Okay, any question on Rolle's theorem and the mean value theorem in finding our c's?
And so what would the answer to that one be?
Right here, c equals 1/3 and c equals 1. So c equals negative 1/3 and 1.
Okay, thank you.
Okay.
And if there's a denominator, is it automatically not continuous?
Well, it depends on this interval right here. You're gonna have to check to make sure. So let's say in that denominator, it was x squared, x to the third, whatever. You know at 0, it falls within here. So no, that wouldn't be differentiable. However,
Okay, but if it was like x minus 2 and it was 2, then it would still
it would,
because
yes,
outside of the brackets.
outside of the brackets. Yeah, so
Okay,
2, yes, you're correct.
thank you.
All right, let's do one more other thing. You should be able to do this if you did on the last one. Where was that thing at? Increasing, decreasing functions. You'll have one of these before you do the graph where you get a sketch. Okay, this should be, by now, this should be automatic for you guys, but this one you will have to fill out the table. Just the one that you don't have to sketch this. But you will have to fill out this table. Okay. So here we want to find the open interval on which x cubed minus 3/2 x squared is increasing or decreasing. Okay, so first thing we want to find is our what? What's it called again? Okay, which one? Yeah, vertical asymptote. Do we have any in this thing? No. Okay. So I don't think we've done horizontal ones here, but there's none here. So what would we take about this function? Take the what of it? Derivative, and that will give us our what? Critical points, good. Okay. Minus, that thing will come down. That's just 3x. And we'll set this equal to what? 0. Okay. So 3x, we're left with x minus 1 equals 0. X equals 0. X equals 1. Okay. So those are our critical points. So how would we write our intervals? Oops. Negative infinity. Next one. Okay, good. Okay. Very good. What could we use as our test value here? -1 would be the best one to use here. And here. Okay, so we plugged in -1 here. This right here will get a positive. +3. This one will be a -3. But we have this, so what would we have? Positive. 1/2. Okay, yeah, it's 3/4 minus 3/2. That can be positive or negative. Negative. 2. Positive. So conclusion, increasing, decreasing, and increasing. Okay. Okay, so write them out. Don't put arrows because I'm seeing some arrows like this. Decreasing, and then I'm seeing some doing concavity. That's concavity, not that, but this I can't tell what that is. Okay, so write it out. Increasing. You could write decrease if you don't want to put the ing in there. Okay. All right. You will have one also for second derivative. You guys okay with that? Okay, for inflection, point of inflection. All right.
Mr. Deere, so can I see what that question was?
Which one?
Yeah.
This one?
I just want to copy down the question.
You don't know how to take screenshots? Aren't you in the tech world there?
No, I don't. I don't think my computer can do that.
I think we're supposed to this year.
Huh?
I think the whatever school said we weren't supposed to take screenshots.
I don't care if
Alright,
you
good,
take
thank
a
you.
screenshot on that one. Okay, so you have to do the second derivative one. They'll have the table and all that for you guys. Okay. So it'll feel like a thick packet, but it's not really. All right. Any other questions? Okay, so we kind of wrap that up. So we did review yesterday and all that. Again, those of you guys are online. Again, I need to be able to see your hands. No calculator, no headphones, nothing headset or anything like that. Okay. All right. All right, you guys. You're free to work on what you need. Just work on something. Let me take roll, and then you guys can log off.